Hi guys, welcome you all to this video. And today in this video we are going to see about bipolar junction transistor. And in this video we will learn about the physical structure of the bipolar transistor, its VI characteristics and how it works. Okay. And in this chapter of BJT, a three-terminal device, we call it as a bipolar junction transistor. The BJT was invented in 1948 at Bell Telephone Laboratories. Three-terminal devices are more useful than two-terminal ones, such as diodes, because they can be used in a multitude of applications, like signal amplification, design of digital logic and memory circuits. The basic principle is the use of the voltage between two terminals to control the current flowing in the third terminal. In this way, a three-terminal device can be used to realize a control source. So, in the introduction, we are going to see what are the functions of a transistor, how, where we are implementing this, or we are packing this transistor. First, to amplify a signal. So a small signal can be amplified or strengthened more using a transistor. In an amplifier we can use this transistor. Second, in a switching, so it acts as a transistor can act as a switch in on and off. So in the higher position we call it as on, or we call it as logic 1. In the lower position we call it as off, logic 0. Okay, these are the areas where we can apply this transistor. And now let's see about the device structure and physical operation. It consists of three semiconductor region: emitter region, we call it N type, base region P type, and collector region again N type. So combined together we call it as NPN. Okay, so however PNP also exists. So we can have NPN sandwich together, or we can sandwich PNP together. So here, for example, we have considered an N-type, some NPN type transistor. So this is an N-type, we call it as an emitter region. This is the P-type, we call it as base region, and this is an N-type, we call it as collector region. So the junction between emitter and base region we call it as emitter base junction, and the junction between collector and base region we call it as collector base junction. Okay, so in the end we call it as a metal contact, we call it as an ohmic contact. This end metal contact we call it as an ohmic contact. So in order to connect the terminal from the collector, as well as here an ohmic contact to connect a terminal from the emitter. This is a symbolic representation of a transistor with three terminals: collector, emitter, base, and the arrow is towards emitter because it is an NPN type. If it is a PNP type, this arrow is marked towards the base. Okay, the emitter terminal, the arrow should be marked towards the base. Next, the simplified structure and modes of operation. The transistor consists of two PN junctions. As I told before, there are two junctions there: emitter based junction and collector based junction. Okay, the operating modes depends on biasing of this junction. So the emitter based junction may be forward bias and collector based junction may be reverse bias. So based on this, there are three modes of operation. One is active mode, cutoff mode, and saturation mode. This active mode is used for amplification. As I said earlier, there are two applications of transistor. One is amplification and switching. So the active mode is used for amplification, and the cutoff mode and saturation mode is used for switching. So the operation of BJT, here it's simplified and given. When it is cutoff mode, the emitter base junction is reverse bias, as well as the collector base junction is reverse bias. In the active region, the emitter base junction is forward bias and the collector base junction is reverse bias. And saturation mode, the emitter base junction is forward bias and collector base junction is forward bias. These are the three modes of operation where both the junction is forward biased or reverse biased. And next, let's see about how a BJT works. So this is a normal structure of BJT with having a base, emitter, and collector. Whenever a supply is given to the base, so you see it's a valve like structure, it pushes up so that there will be flow of electrons to the emitter. Emitter is n type, collector is n type, maybe the base is p type, this base is p type, so that this can be the flow of electrons can be from collector to emitter towards like this, towards the flow can be like this. This can be pushed so that the flow can be like this. Okay, this is a symbolic representation of that. See, the collector current is IC, emitter current is IE, and the base current is IB. So whenever a supply is given, what will be the emitter current? The current in the emitter terminal will be the addition of collector current as well as the base current. See, look at the diagram, the second diagram. So whenever a supply is given to the base terminal, the end gets, the closure of the switch gets open, so that there will be a flow of electrons from one terminal to the other, including the base. So the emitter current will be equal to collector current as well as the base current. So among these three modes of operation, the active mode is very important, and it is most important mode in the transistor. So there are two external voltage sources are required for biasing to achieve it, and the current flow in an NPN transistor biased to operate in the active mode. And see the internal structure of the NPN transistor. So this is an emitter, this is a base, and this is a collector, and this emitter have electrons, okay, which is injected. This n-type region is also having majority carriers as electrons, and whenever supply is given to the base, so the electrons from both n-type are recombined in the base, okay, so that, and it is moved toward the emitter. So finally the emitter current will be equal to the base current plus a collector current. This is for, so this emitter base junction will be forward bias, and collector base junction will be in reverse bias condition. Okay, so it is observed that most diffusing electrons will reach the boundary of the collector base depletion region. Here a depletion region is formed, as you can see the video in the previous unit, PN junction diode. I have explained clearly how the electrons and holes are attracted towards and how the depletion region is formed. Because the collector is more positive than base, these electrons are swept into a collector. Okay, so the collector current is approximately equal to the emitter current, which is addition of base current and collector current. So these are the three regions of operation, as I told: cutoff region, saturation region, and this is the breakdown region. So this is the cutoff region, saturation region, and this is the breakdown region. And symbolically we have shown the circuit diagram. So there's a base, collector, and emitter. The voltage across collector and emitter we call it as VCE. The voltage across base and emitter we call it as VB. Here we have drawn collector emitter voltage in x-axis and collector current. We are drawing the graph voltage across collector emitter and collector current. Okay, so now as the voltage of collector emitter voltage gets increased, the voltage across this collector and emitter is increasing more and more. The collector current increases, and it moves on to the saturation, and it gets breakdown. So if for a base current of 0, and what will be the for a value, another value of base current, and what will be the for another base current, we'll fix this base current and we'll note the readings of the voltage across this collector emitter voltage and collector current. The characteristics of each regions of operation are summarized below. So in the cutoff region, as you all know, base emitter is reverse biased, so there is no current flow in the cutoff region. Okay, so in saturation region, base emitter and collector base junctions are forward biased, so the collector current reaches a maximum which is independent of the base current and current gain beta. Okay, and here the collector emitter voltage is less than the base emitter voltage, so there is no control. Next is the active region. In active region, the base emitter junction is forward bias and collector base junction is reverse bias, so that the base emitter voltage is less than the collector emitter voltage, which is again less than the supply voltage VCC. Now the collector current is equal to beta into IB. IB is nothing but base current. Okay. Next region we call it as breakdown region. Here the collector current and collector emitter voltage exceeds some specification, damage to the resistor. After this, if we increase the supply of the transistor gets or the device get damaged. Okay. And here I'll give you an example of BJT application. So RB is a resistor, we are giving a supply, and RC is a resistor, collector resistor, RB is the base resistor. Now it is in off condition. So off in the sense the transistor area, I told you transistor can act as a switch. So transistor in off in the sense it's open condition. Okay, both junctions are reverse bias. And now when it is on, the transistor, this area is short circuited. That means the transistor, there is a flow of current through this transistor. Okay. So in another applications can be transistor can drive the motor. To drive the motor, we use transistor. A transistor can also use to drive and regulate the speed of the DC motor in a unidirectional way by switching the transistor in regular intervals of time. The DC motor is also an inductive load, so we have to place a freewheeling diode across it to protect the circuit. By switching the transistor in cutoff and saturation regions, we can turn on and off the motor repeatedly. It is also possible to regulate the speed of the motor from standstill to full speed by switching the transistor at variable frequencies. We can get the switching frequency from control device or IC like microcontroller. Okay, so I think through this video you gain knowledge about bipolar junction transistor and what are the modes of operation, maybe the active region, saturation region and cutoff region, and the VA characteristics, how to draw the VA characteristics and the basic principles behind and the basic applications of BJT. So hope in the next video we will continue the bipolar junction transistor configurations in common emitter, common base and common collector. Okay, thank you.